process of mixing concrete.
In this video, we're going to talk about the process of mixing concrete mixture. The raw materials used are cement, as you can see what the workers do. They are carrying the cement bag right now. So what do you do next is to pour into the concrete mixture. So typically, we're looking at the portable concrete mixture with a small bowl with drums. Make sure that mixing of cement and water to produce concrete. So right now, the workers are preparing 4 buckets of water and getting ready to pour into the drum of portable concrete mixture. So the reason of adding water to make sure that it will have right mixture ratio of cement and water to produce concrete. As you can see right now, the workers will be adjusting the speed of the machine to ensure that the mixing is at a smooth rate. Now, the workers are clearing the wheelbarrow to getting ready to pour mixing concrete into the wheelbarrow and transport to the nearest constructing spot.
Construction process of brick cavity wall.
The brick installation starts by mixing mortar, which must be prepared and maintain the temperature about 40 degrees Fahrenheit. Several moisture management features exceeding a standard brick veneer wall. A drainage cavity is created by the 1-inch air gap between the brick veneer and the covered shading. This cavity allows water to drain out of the wall system and promote drying of the wall materials. Flashing is located the critical interfaces such as the exterior wall and foundation window and doors itself. There are many flashing products to choose from this building using a flexible flashing material. £15 felt building paper is installed over the flashing and hose rod, providing a second weather resisting barrier, although 2 WRB layers are not required by the local building code. The second layer is capillary break, which can minimize the water transmission due to mortar breaching because of the mortar dropping from wall tiles.
Weed holes are critical drainage features because they allow water to drain out of the wall cavity. Weed holes can be created with this spacer product of clear opening, which must be spaced to the maximum 16-inch on center or 24-inch on center respectively. Wall tiles are designed to anchor the brick veneer to structural shading, to spacing and anchoring detail are critical to the installation of brick veneer wall. The wall must also accommodate penetration for electrical and mechanical utilities. Protective tube is placed over the utility service line and the brick units are custom cut to allow the wall penetration. When flashing is installed underneath the window of door opening, a dam fissure must be added to the end in order to direct the waterway from the cavity and toward the exterior. The brick installation is continued and weep hole fissures are added at the sole location beneath the window. A brick window sill is fashioned and anchored to promote the drainage rain away from the window and the wall cavity. The flashing underneath the door opening will be similar to the window sill area, including a dam fissure and weep hole.
This is the detail of brick cavity wall. This is the metal stud 16-inch on center to center. Form insulation joints are tapped and offset to prevent air infiltration. 5/8 inch of gypsum board. 4.5 inch of combined insulation. Insulation slows the movement of heat from a warm space to a cooler space, saving money on heating and cooling. The TDS received LEED point for using material within 500 miles of king. The function of air barrier and vapor retarder is to prevent air from moving through the wall, slow down movement of water in gaseous state. The outer layer of insulation is a weather-resistant barrier. The tape functions together with the insulation board. Moisture is captured and guided away from the wall by better flushing. Anchor bolts tie bricks through insulation to start. The 4-inch air cavity is used for mortar drops and also stops liquid water from moving into the wall. This allows water to evaporate or run down the back of bricks and out through the flashing. non-harming adhesive applied to interior gypsum wall. All adhesive, sealant, paint, and coating are low-emitting volatile organic compounds, meaning they are non-hazardous and improve indoor air quality. Polish low and non-emitting concrete floor minimize pollutant in the air. Locker fill is from the building Old Adam Tech Building and Butterfield Cottage. It has been crushed and compact. 3 inch of foam insulation outside of the foundation. 3 inch of insulation. Local stone. Local pavers. Construction process of diaphragm wall.
The construction methodology and excavation option for the diaphragm wall are explained in the following sequences. Shallow guide wall is constructed first along the alignment of the proposed wall. The guide wall serves to locate the excavation equipment within acceptable tolerance before the retaining wall constructed commences. The guide wall is made from reinforced concrete, typically 1 to 1.5 meters deep. Walls are constructed to type vertically tolerance. Excavation of the diaphragm wall is carried out in panels. A typical panel is excavated in 3 bites, a left bite, a right bite, and lastly, removal of the middle dumpling white wicks. Depends on the grab type being used, but 2 to 2.8 meters wide is typically at the same time as the soil is removed from the panel. Bentonite mud is pumped into the excavation to support surrounding soil, preventing collapse into the excavated trench. Excavation continues until the bite reaches the designed depth. Bentonite mud or an appropriate circumstances polymer is best in an on-site plant allowed to hydrate to gain full chilling properties and is then used for temporary excavation. Support typically bentonite powder in bulk or bag form is added to the water and rapidly mixed in corridor mixer to produce the desired concentration of bentonite mud. The mud is usually pumped to a storage tank where it's hydrated for up to 12 hours. The better light particles swirl and absorb the water before it's used to support the excavation. When required, the hydrated mud or recycled mud or a mix of two is pumped to an excavation trench to replace the excavated soil, maintaining a constant head of the mud above the prevailing groundwater levels. Excavation of the panels continues, generally completing left and right bites before removing the center bites. Then, the center bite is excavated down to the required panels to level steel or precast concrete. Stop ends are placed at the edge of the excavated panels. The stop end may contain a rubber water bar that later becomes embedded into the concrete. The water bar minimizes water ingress between panel joints. Once the earth is excavated inside the diaphragm wall, prefabricated reinforced cage is then lowered into the excavation between the stop end blackouts for fall slab connection, ground anchors or other penetration can be formed in the reinforced cage. Concrete is poured into the excavation using the tree method. This is achieved by use of a hooper and steel tube extending to the base of the excavation. Typically, the hoopers are used for a 6-meter wide panels. The hoopers and tubes are charged with concrete, then the tubes are lifted off the bottom of the excavation so that the concrete flows out. Displacement of the light of bentonite mud upwards the bentonite is pumped back to the recycling plant. As is displaced as the concrete level rises in the panels, the training tube lengths are shortened to ensure that the flash concrete is always closer to the concrete bentonite interface. When the concrete rises to the required levels, the training pipes are removed and the concrete is allowed to sit. The first panel constructed in a run of wall is called the primary panel. During concreting, the excavation grab and base crank is moved to another location. A safe distance from the concrete panels and excavation recommend on another primary panel. The next excavated panel is completed and concreted in the same procedure as just described. Subsequent panels excavated adjacent to the completed panels are called secondary or running panels. The final panel in a run of all is called closing panel. As this panel closes up the length of wall, the stop end is removed from one panel during excavation of the adjacent panel. Diaphragm wall panels can be excavated using several types of equipment, including hydraulic cutter. These are powerful machines capable of excavating into hard rocks but require large bentonite plants at large crane to hold the cutter. Steering mechanisms are built into the grab body to provide a high degree of vertical control. The hydraulic grab. This type of grab has hydraulically operated closing jaws and so is able to exert considerable closing forces to excavate dense sand, stiff clay, or weak rocks materials. These grab bodies can include steering mechanism. The pulley grab. This grab uses only pulley forces to close the grab jaws and so is more suited to softer ground. And the caddy grab. This grab type is rigidly suspended from the base machine, whereas the three previous types are rope suspended. The caddy grab can provide reasonable excavation forces and vertically controlled but may not be as fast as suspended grab excavation. Typical diaphragm wall widths are about 600 mm, 800 mm, 1200 mm, and 1500 mm. No other size can be used for special requirements.